Very good morning, sir. My name is Tristan Hancock, C028 B1 batch. Today I will be presenting to you my IP project. Today's topic is going to be face detection in an image. So previously I built this project using machine learning. However, we are not allowed to use machine learning. So for this time I have used the image processing techniques detect the faces. So quickly I will run the program and then I will explain through. So let's start. And we're taking an image called face 1. You can see this is my image. Now we will run it. I will explain everything in a second. As you can see, have face is detected. Alright. So it is drawn a rectangle box as I have specified over here to draw it around the detected faces. It is drawn a rectangle box. Now let's take an image that is not a face that we can actually see whether the model works or not. So I have this image over here. As you can see, there is no face, there is nothing here. It is a simple nature picture. Now I am going to comment this, and now you can see no face I have taken. I will now run the program, and here, as you can see, I am getting an output saying no detected. So now I will explain how I am doing this. And one last part, since this is not machine learning, this method is not very accurate because we are using something known as contouring. And essentially what I am doing in this program is, first of all, I am converting the image to RGB color spaces, right? And using that, I am then converting it to HSV color spaces. HSV color spaces is mainly used for things like skin tones, skin in general. That's why I'm using HSV color spaces, and it basically stores information in a cylindrical representation of RGB color points. So after we convert to RGB, it's then putting it in a cylindrical representation, and then from there, we are able to detect things like skin tones and things like that. So now what we're doing is we're actually taking a range. So we need to understand that since it is simply using a range to detect skin color, it might not be very accurate. Some people's skin might be outside that range. Maybe it's darker skin, maybe it's very light skin. It might be outside that range. So we're taking two arrays, that is lower skin, and then we're taking upper skin. Now, what is that going to do is that's going to set a range, like I said. Now, we are then creating a binary mask to actually detect what those pixels, what like those pixels fall in what type of skin color range. After that, we find the contours, right? Now, contours are basically the boundaries that are connected regions in that binary image. So, whatever image we're getting, we will have a like a boundary around it, allowing us to detect that specific image in that face in that image. So after that, what we are doing is filtering out the small boundaries that need to be removed, using a threshold, and that's how we are separating it and making it a bit more accurate. Now, after that, it's simple. After that, we are simply just looking for if the length is a less is equal to 0. If length is equal to 0 of whatever we've discovered, then it is no face detected. And if it is, then what we can do is we can draw a simple rectangle. That is how we are using in this project. And like I said, it's not very accurate, but image processing is the best way to do the in contouring and HSV color space. And that is all. Thank you so much.